Today we need to look at tangents and normals to exponential graphs, and we need to get back into the habit of finding the equation of a straight line, which would be a tangent or a normal to one of these curves. Now, reviewing the basic features of our two main curves. We call these our two main curves because the basic y equals e to the power of x curve represents exponential growth, and we see this all the time in finance, in cells dividing, all kinds of places in nature. But equally important, y equals e to the power of negative x, which of course is the reflection across the y-axis, represents exponential decay, and we see that a lot in nature too with things like half-lives. So the basic features of both graphs, they have an asymptote along the x-axis, and they both pass through a y-intercept of 1. Now, even more importantly, we've already learnt that right at the y-intercept here, our basic exponential curve has a gradient of 1. That means that the tangent to the curve also has a gradient of 1. So this would be the line y equals x plus 1, because it's going up at 45 degrees, but it's lifted up 1 unit from the origin. Similarly, if we've reflected this across the other way, then our exponential decay graph, as it goes through the same point, would have a gradient of negative 1. So this line would have the equation y equals minus x plus 1. And you'll notice that here, if we have both of these gradient of 1 and gradient of negative 1, then they'll actually meet at right angles as well. So let's write down a few notes that will help us with today's exercise. We're finding tangents and normals today. Now remember, a normal to a curve is perpendicular to the tangent. So if we have any kind of curve at all, then a tangent will just touch the curve once at that local point, but a normal will be at right angles to the tangent. So you might be asked to find the equation of the straight line that is either a tangent to a curve or a normal to a curve. Now, we've just seen on our last picture that y equals e to the power of x and y equals e to the power of minus x actually meet at right angles at that point 0, 1, at their y-intercept. So in fact, if they're meeting at right angles and they're perpendicular, then one is a tangent and one is a normal to each other's curves. And we know this because their gradients there are 1 and negative 1. And we've already seen in our previous work this little formula, m1 times m2 equals negative 1 for perpendicular lines. So in other words, if we can multiply the gradient of two lines together and we get negative 1, then the lines must be perpendicular, which was the case a moment ago. Now, for the rest of our exercise, we're working on exercise 9D at the moment, we need to be able to find the equation of a straight line that is either a tangent or a normal. So let's write this down. To find the gradient of a tangent, we need to differentiate the function and then sub in the value of x required. So if we're asked to find, say, the tangent to a curve when x equals 3, then of course we want the gradient of this line when x is equal to 3. We start with the gradient. Now if we need to find the gradient of a normal, then we need to start by doing the exact same thing. You need to start with the gradient of the tangent at that point, and then you'll need to find its negative reciprocal. Now, I've written negative reciprocal here because you've got two methods that you can use to go from the gradient of a tangent to the gradient of a normal. You can sub the one that you know into this equation and solve the equation to find the other one. Or, for example, you can just take the negative reciprocal. Now what I mean by this, if I found that the gradient of a tangent was, let's call that m1, was say 2, I could sub it into an equation like this and say 2 times the other gradient has to be negative 1, and then solve that equation for m2, divide both sides by 2, and I'll get minus a half. Notice how 2 and minus a halves have some things in common. 2 and a half are the reciprocal of each other. That's what we mean by find the reciprocal. Flip it upside down, in other words. And change the sign. So if the first gradient was positive, the second one will be negative, and vice versa. So that's a shortcut that you can take to go from the gradient of the tangent to the gradient of the normal, or back again. The other thing we'll need is this old formula, y minus y1 equals m outside of brackets x minus x1. And we use that to find the equation of any straight line. So all you need to know is one point, x1, y1, which is on your curve, and you'll need to know the gradient at that point, and you can sub your x1, y1 and gradient into that formula to find the equation of that straight line, whether it be a tangent or a norm.